Hello guys, gals and MBs. Let's take a look at this little TOON shader today. So this is a little component that I've made, which allows you to generate some TOON shading for your projects. It's available on GitHub and I've linked it in the description. And there you can get it and use it for this project. And there is also the example project, example file for this project that I'm using, which if you download that and also download the example project and the cross-hatch render, you're going to be able to follow along with this tutorial. It might look a little bit different than it does in this tutorial. That's because I am continuously updating it and changing it a bit. And that's also why I'm using GitHub, is because it makes it a little bit easier to update stuff and make changes. So yeah, let's get started on this. Okay, so this is the example project, but let's create our own little project from scratch here. So I'm just going to create a base here and step inside of it. And let's see. The first thing we need is some geometry, right? So let's have a torus, and let's create a little chain situation. So I'm just going to turn the radius down a little bit. I'm going to orient it in the z-axis, and then let's copy it a few times. So let's copy it, like, let's say 5 times, and let's translate it upwards by, we could actually grab this radius just for clarity. So we translate it up by its radius every step, and then we also, whoa, that was the wrong slider. So yeah, let's give it a moment to go back home. And obviously I meant to rotate it. So we rotate it 90 degrees per turn. Let's say times 1.5 the radius. Yeah. So there we have a little chain of toruses, and we can also just create some dynamics, create a little bit of rotation here every step. Yeah, that's a fun little shape. Let's go to a null here. And let's also create a floor that this is sort of stretching out of. So let's create a plane actually. And let's make sure that's in the XZ direction, and let's merge these. And that's a very small floor. So let's turn the size up a bit, and let's just transform this up a touch. So we can move it up a little bit. Yeah, something like that. That's our geometry for today. So normally we can chuck this into a geometry, right? Dunk. But let's instead for today, let's use the cross-hatch render. So you can use the cross-hatch render talks, and it's throwing a warning. Yes, and it's throwing a warning because light and camera aren't referenced. So let's make sure we have a light. It needs a light to work, and it needs a camera to work. You can assign those to here, right? And then we'll just drop down a null and have a let's have a constant as our background, because I want my background to be white, so I'm setting the constant to under. And yeah, let's just move our camera back a little bit and up. And here we see an issue pretty immediately. And that's because this one has the point attribute of texture, while this one has the vertex attribute of texture. So it's always going to pick the vertex attribute if you have one, and then just ignore your point attribute. So it's good to have all of the things that's going in should be of the same class. So let's convert this texture coordinates to a vertex. And that looks okay for now. Let's create a null. Just something for our camera to look at. And then we can move it around a little bit more. And let's move the null so it's actually looking up at our statue a little bit. Something like this, right? Now, one thing we might notice here is that I've tried to mitigate these texture repetitions as much as possible, but it's actually quite difficult. One thing we notice here is that there are different scales, so we can actually use the texture map pop, and let's just transform the input texture chord, and we can scale these maybe up a bit so that they're sort of in scale, the texture chords, and then we can set our light, and let's make our light a cone light, and let's move it back a little bit, something like this, and let's turn shadows to soft shadows so that we have some dynamics in there. Yeah, so simple as that to use this. And then if you want to customize this a bit, you can make changes under the material tab. You don't need to unless you want to. I think it usually looks better with a little bit of a Fresnel rim light. Yeah. We can also invert it to have it be sort of light on dark paper, so to speak. And this obviously looks a little bit better with a darker background. So yeah, white on dark paper with the invert. This one is how much we're sort of blending or having a blur for our texture map. And that can be really useful for creating a little bit softer transitions in the hatching. The thresholds, that's the sort of min and max thresholds, can be useful for various reasons. The hatch color, so that's the color of your hatches. So yeah, can sort of select the color of the ink a little bit more. Hatch alpha should describe itself. The outline sort of sets the width of the outline and the strength of the outline that we have in this shader. And yeah, let's look at the TAMs here, the tonal art maps. So we can set the UV scale sort of uniformly to change the scale of the UV, just to fine tune that if you need to. It's obviously better to do it in the model, but here you can sort of fine tune it a little bit. Now, everything else on this page, if you change it, nothing's gonna happen, right? So it can be, the way it works is that you set this up and then you hit generate TAMs and then it generates for you. So the TAM count sets the amount of tonal art maps we're using from just 2 tonal art maps. I like to use around 8 for some more variation. something you can set up, the TAM resolution. Here, higher is obviously better, but lower is obviously more performant. So try to use as low as still looks good to you. And 256 might be more than good enough for this. Yeah, we can also select the shape here. So here we have more sort of crisscross pattern. We can have it drawing little circles. We can have it drawing lines and also dots. So dots usually look better with quite high density, and often it doesn't even look that good. I like lines. Let's set that to 100. Let's set that to 75, something like that. And yeah, and this rotation, it's like halfway through the TAMs. If we look at the TAMs for a second here, I'm just gonna open a viewer here. We can see that we have horizontal lines, and then halfway through, if we set this to 90, rotate B, it's going to start rotating half of them to 90 degrees after a while. So yeah, you can set these up to whatever angle you sort of want them in. I think it usually looks good to have these at something like a 45-degree angle. Yeah, especially with lines and crosses. The line width sets how wide the widest part of your line is. So if we set that to 1, we get narrower lines, and this is the case where maybe a little bit of a higher resolution is good. So yeah, that's the TAMs page. Under the render settings, we set up our render resolution like in a normal render top. Yeah, and this is from the screen space ambient occlusion top. So here we can set our SSAO settings. That's you may not need to really do much here. Yeah, it can change a little bit, sort of the look. And screen space ambient occlusion is the sort of the contact points, right? So how it's contacting surfaces, touching surfaces, and how much sort of they are occluding from the light, which isn't modeled. It's sort of, yeah, it's done in screen space. So yeah. Yeah, this is the shader, and this is how you can use it. Let's go over a little bit how it works if you're ever interested in doing your own thing like this, or trying it out. Oh yeah, I forgot to talk about some things. So another thing you can do here is that you can set, for example, the different colors. So for example, of these object, if we have an attribute here and we name this to color, we can actually set the color of our objects. So yeah, if you want to do a little bit more TOON shady stuff, and this is a constant color per object, so it's, yeah, that probably makes sense to you. So we can, if we, for example, we output an attribute here, and then we can set a noise here, and maybe I don't want to do that. I'm gonna create, before that, I'm gonna create an attribute here for color and chuck that up to 1, something like this. And then we can output this into the color 0, 1, and 2. And let's multiply it. And let's set the offset to 0.5, and let's set the amplitude to 0.5. This doesn't look great. Let's actually look up the color, the copy ID. If we set this to something like this, and maybe something like this, maybe a Perlin. We can turn this down a little bit, turn this up. Yeah, there we have some nicely colored rings also. Could be the move, could be the move. I'm actually gonna take these colors and just do a math and take the color and let's just do this to 0, 1, and 2, red, green, and blue. And let's post operation normalize them. So all of their length is 1, just to keep it a little bit more in check. Something like this, maybe. Yeah. Yeah. Let's create a little bit of camera movement. You can figure out how to make your own camera movement here. I believe in you. Yeah. Let's talk a little bit how this works under the hood. So it is inspired by this one. This paper, it's a simplified version of what this paper describes. And I really like this little, instead of PBR, physically based rendering, it's MPR. It's non-photorealistic rendering, which is something I obviously aspire to. Anyways, it talks about sort of creating tonal art maps. And a tonal art map, a TAM, is different levels of shading, right? So it goes from bright to dark. So we create sort of a texture lookup of these different art maps, or tone maps. And then we look them up. Depending on how bright a pixel is, we sort of switch into different ones of these. They're doing it per vertex, I'm doing it per pixel. And yeah, so and it's looking up on the UV chords. I'm also using a 3D texture here for my TAMs. So yeah, the TAMs are generated with just a bunch of pops and a little bit of Python just to generate the different iterations with the Python. And then all of those get stored into a text 3D top. So we generate them and we chuck them in there. Right? And then in a GLSL top, we do a bunch of stuff, but one of the things we do here is that we're looking up the textures, and in the Z direction, which is the depth, we're using the shading, so this from the render. So we're taking the luminance of this and we're sort of deciding which one of these should we go into. And this is after doing some screen space ambient occlusion and also blurring it out a little bit. But another thing I'm using here is the wonderful new feature in the Phong mat, which is under the Advanced tab. We have the opportunity to output 2 different buffers. And in those different buffers, we can actually output different stages in the shading. So we can, for example, output just the text chords, and then we can use that in our project later. We can also output just the point color, and then we can use that in our project as a texture, and the depth. And in this case, I'm using the depth essentially as in order to generate the edges. So this is in order to get these sort of overlapping. When they're overlapping, it's creating an edge. Yeah. And in the shader, if you're interested, that's done with what's called a Sobel filter, which is essentially a fancy slope. So it's a fancy slope function, and then we're taking the edge here, which we're taking the length, so the magnitude of that Sobel filter, because the Sobel filter is a 2-dimensional vector. Yeah, and then we're just adding that in, or applying that to our hatching. So yeah, yeah, we're doing some shenanigans with the shadows also. Not gonna go in too much into that. Yeah, so that's essentially how it works. So yeah, I can show you how to use that sort of Phong situation. So for example, if we have a sphere here and we chuck that into a geometry, we have a camera and a light, and we use the Phong material and we render this. So yeah, here under the Advanced tab, you can select which stage of the shading we want to look at. So for example, we can look at the world space positions, we can look at the world space normals, the camera space position, the camera space normals, yeah, the point color, anything here that sort of goes in, we can bring out to a rendered or rasterized texture, and we can use that for whatever purposes we want. And in order to have many of these, let's say we want to have one with point color, one with world space pulse, and one with texture chords, and then one with the full shading, right? So we can use a render select here, and we can select which buffer we want. And here we set up the buffers. It's throwing a warning. There's no color buffer for the specified index. That's because we also need to set it up in the render how many buffers we want. So here we're selecting how many color buffers we have, and we have 1, 2, 3, 4. So let's set up 4 color buffers, and let's have it like this. So here we go for number 2, and here we go for number 3. Yeah, and then we can use these however we want, if we want to perform any sort of shading with it or anything like that. And it works really well. So that's a lot of what I'm leveraging in this project in order to not have to do all of this inside of the shader. And it's also kind of, in my opinion, a pretty good way, because we can actually use the screen space ambient occlusion as part of our sort of TOON shading here. So yeah, I really hope you have fun with this one and make some beautiful and interesting works. So yeah, let me see. As I said, I'm sharing this on GitHub. But also, please do support me on Patreon. The link is in the description. And yeah, go nuts with it.